Hi everyone. Today I'm going to show you guys how to solve a question that was at the naval that was put in the it's one of the questions that was in the entrance exam of the naval school in Brazil. It was in 2015, 2016. I don't know if those guys in there had just pen, pencil, and an eraser, and just maybe one sheet of paper for a sketch, and they had to solve this thing in like 2 to 5 minutes. So those guys are good. I wish I were that good. Well, there are two ways of solving this thing. Okay, you can use triangle similarities, but I don't want to do that because if you do so, you're just going to make a mess in the whole drawing. You're going to have to draw so many triangles in there that by the end of it, you'll barely be able to understand what you've done, if at all. Okay, I just don't like it. So what I did is that I devised the coordinate system, 3D coordinate system, where you have X, Y, Z. We're using the right hand rule. And I created a bunch of key points in the drawing so that I can just use simple vector math to find out all the coordinates of the points and calculate the stuff. Okay, now here's the question. Consider a right triangular prism whose edges have the same length. Whose edges have the same length. So you see from E to B, from E to F, from let's see, F to D, D to A, they're all the same. The prism is split by a plane formed by two vectors. In this case, the vectors G, from G to H, from H to I. Okay. The prism is split by a plane formed by two vectors. The first vector starts at the midpoint of a base edge and ends at 5/6 of the height of the prism on a vertical straight line that connects the bases and tops apothems, I guess. Apothems. The second vector starts at the letter point and ends at the midpoint of any of the other top two edges that don't correspond to the base edge where the first vector starts at. Find the ratio of the smaller volume of the prism on one side of the plane to the larger volume of the prism on the other side of the plane. So it's kind of complicated. You see, there's going to be a vector from G to H, okay, and then another one from H to I, and these two vectors, they form a plane in 3D. In this plane, you know, you're going to make it grow. This is just a small shape in here, but you're going to make it grow, and it's just going to split this prism here, and you have to find the ratio of this side closer to the camera to the other side behind the plane. So it's going to be this volume here closer to the camera, to the volume of the prism behind the plane here. And so I created all these key points in here, and we're going to find the coordinates of all of them together, right? Because I think it's easier than trying to use triangle similarity. I didn't create this wireframe by myself because I have a hard time rotating things in my head and still keeping perspective. I'm not a very good drawer, artist. So I'm going to show you guys something else here that I made. You see, I use this 3D animation software here to do this stuff for me. So this is a prism where all the edges are the same, right? See here the height and all the stuff. And it's a triangular prism where the base of the triangle is equilateral triangle. It's one thing that I forgot to put in the question. These triangles here are equilateral. Okay, so you have over here, I did some X-ray on shaded. So you have this thing here. I'm going to show you guys the wireframe. This is one of the vectors without this green part here, just this part right here. Okay, and this is the other vector. And these two vectors, this is one of the vectors, and this one right here where the mouse is the other vector. And the third vector in here is just closing the plane. So when this plane grows, it becomes this stuff in here, looks like a piece of glass, right? Look at the size of that thing. And it splits the prism right there. You see it? So you got this part right here, which is a smaller volume, and you have to find the division, the ratio between this smaller volume and the greater one behind the plane. So you see, since the prism is triangular, the plan of attack is to make a triangular pyramid where this plane is going to be one of the sides of the pyramid, and the other two sides are going to coincide with the side of the prism. This side right here is going to be part of the it's going to be one of the sides is going to coincide with one of the sides of the pyramid, and this other side right here of the prism is going to coincide with the other side of the prism of the pyramid, right? Because there's going to be then 3 sides to the pyramid. One side, the third side is the plane, the second side is the plane, and the third side is this one here. So I drew this stuff here in 3D. So here you have the pyramid, right? So you have one of the sides here, and you got the second side here, and the third side right here. And it's just getting into that prism, right? And well, why do we do this? Well, because you have to find, you got to find this part right here. Okay, now this part right here, the larger volume behind the plane, is the one that's going to intersect between the volume that intersects. That's part of both the prism and of the pyramid. Okay, I'm just going to get this wire, this X-ray here out, so it's a little bit easier to see. Okay, so the plan of attack is that now, since we have all these sides in here, this side and this side coinciding, and this side and this side coinciding, okay, what we're going to have to do is to find all the key points. With the key points, we're going to be able to find the base of the large pyramid of the whole thing, right? And then we're going to get from the base of the pyramid, we're going to multiply by the height divided by 3 and get the volume of the entire pyramid. And then we're going to subtract from this entire pyramid the volume of the smaller pyramid in here on top of the prism. And then we're going to get this little part here out too. And with that, what we're going to have is just the part of the large pyramid that's inside the prism. And that's the larger volume of the prism that you're interested in. And then all you got to do is to find the volume of the prism and subtract from the whole volume of the prism this part of the pyramid that intersects, and you're going to have the smaller volume of the prism. I know it sounds complicated, but we're going to do it together. And then once you find the smaller part to the larger part, you just divide them. And the answer, for anybody that wants to know, is 49 divided by 95. Okay. Now I'm going to show you guys how we get to this. Oh yeah, I don't recommend watching this video on a cell phone or on any small screen, because I'm gonna have to write a lot of things, and things are just gonna they're gonna get very tiny. Okay, so if you're watching it on a tiny screen, they're gonna get even tinier, and it'll be hard for you to see. So if you can, just watch this video on a computer monitor like 1920 by 1080. All right, so here we go. You gotta make some assumptions here. So the floor is made by the XY plane. Okay, so this is X right here, and this is Y. All right. So from A to B is X, goes along the X coordinate. From G to C goes along the Y coordinate, and from B to E, from A to D, from C to F, you're going along the F coordinate. You're going along the Z coordinate, the Z axis. Yeah, I'm sorry. The coordinate system is made up by the right-hand rule. All edges have length value of 1. Okay? So this is 1, 1, 1, 1, 1. Okay, good. So first, we're going to start with these things here. I put all the key points on the right side, okay? And I'm going to explain why these things. Okay, so I just started like point A is going to have coordinates 0, 0, 0 because I want this to be the origin right here. And then B, well, it's just going to be 1 unit to the right in the x-axis, So you're going to have 1, 0, 0, 1 for x, 0 for y, 0 for z. All the points on the floor are going to have 0 for z, and all the points on the top here at the lid at the top of the prism are going to have 1 in z. C is half y, half in x. Okay. A lot of people already know, because this is an equilateral triangle, a lot of people already know that the y value for C is square root of 3 divided by 2, but we're going to find that together. So I put a question mark in here, and it's 0 because it's on the floor. Now you have D. D is just it corresponds to A, E corresponds to B and F corresponds to C, but this time it's on the top of the prism. So it's going to have the same X and Y values. See, A00, D00, B10, E10, C half and question mark, F half and question mark, except that the Z values are 1 this time. Okay, G is the starting point where the first vector starts from. Okay, its value is going to be half in X. Why? Because it's just going half this way. Okay, and 0 in Y, because for you to increase in Y, you have to go in the direction of C. So if you go along this line here, the direction in Y is just going to be 0. H, it's half in X. It's a question mark because a lot of people don't know that the apothem, well, you see the H is going to be a point on the vertical line that connects both the median of all the apothems at the base of the, from the base of the prism to the top of the prism. So to make it a little bit clear, you see this is an apothem here, this is one, this is another, and this is another. Of course it's the height, okay, but from the center, you see where the apothems are gonna meet is one, it's the point J, and up here on the top of the prism you got all these heights in here, okay, and they're gonna meet in the same place where the apothems are gonna meet, and this is the K point. All right, I know it's kind of very complicated, but hey, what can I do? This is a complicated question. Okay. H is going to be on this vertical line at 5/5 the height. So what's going to be? It's going to be half for X, because it's half for G2. It's going this way. And then it's a question mark. Of course, a lot of people that know these things know that the value here is just going to be 1/3 of the way. So it's going to be square root of 3 divided by 6. But we'll find that together. And H is going to be 5/6. Why? Because the question says that it's at 5/6 the height of the prism. I is going to be this point right here. Okay, it's the point where the second vector ends, because the second vector starts from H and it goes all the way to I. I is going to be a question mark, and 1. I mean, from the drawing, you just know this. J, where's J? J is this point right here. Okay, it's here and it's also here. It's the same thing. So all we know for now is that J has half, a coordinate of half for X, and 0 because it's on the floor. K, let's see. K is this point right here. Okay, so K is going to have the same coordinates as J in the XY plane, except it's going to have a Z of 1 because it's on the top. L is going to be, you see, you go from, if you follow this vector from G to H, at one point, if you keep following this vector is going to cross the top of the prism, and it crosses at this point L. So all we know for now is that it's half, because you see from G to H, you're not changing the X coordinates, so L is going to have half too for X, and it'll be 1 for the Z. And the question mark in here is because we don't know how long in Y it's going to be. Okay, M, it's a point, because you see, if you go from G to H, and then you're going to go to L, eventually you're going to keep going, and way up there you're going to hit the point N. Okay, the point N is immediately on top of this point F in here. Now M, you see, let me explain something to you guys here. I is on the top and it's part of the plane. L is also on the top and it's part of the plane. So if you go from I to L in a vector, you're going to hit M over here. Okay, which is also part of the plane, because IL is a vector that's on the plane, so ILM is also on the plane. So N is going to come down all the way to M, and it's going to hit Q, okay, and from Q it's going to hit O on the floor. O will go all the way to G, and G is going to go all the way to P. So we have to find all these things. So you can inspect this thing here. I'm just going to stop talking about this, all these values here now, because it's boring. You can just pause the video and inspect the stuff for yourself. Now here, you see this, what I'm going to do is just to worry about this prism here. And I put a bunch of letters that do not correspond to this one, to these ones. Okay, I just created a unique system here to the top. So see here, top of the prism, the letters shown here, not the ones of the 3D drawing. Okay, so why did I do this? See here, I want to find out how the value of y here for b, because this b, it's actually gonna be on the, it's gonna have the same y value. This is a height and this is a height. Okay, so I'm gonna have the median of the apothems here, and I already know the x of the apothems. I already know the z because for the h here is 5/5. Okay, but I don't know the y, so I need to know how far it is from E all the way to B here. So I put all these things in here, okay, and you can inspect this stuff. And here I'm just gonna keep going. So for example, D is gonna be R sine of 60. What's gonna be D? This D here, it's actually the C here or the F. It doesn't matter, okay. So what's going to be this stuff? Well, this is 1, this is 1, this is something that we don't know what it is, and this is half. Here you got a right triangle. So D is going to be R sine of 60 because you got a 60 degree here. Well, how do you know this is a 60 degree? Because the triangle is equilateral. So it'll be R, which is 1. It's from this point to this one here. Times sine of 60, which is square root of 3 divided by 2. So D has coordinates half square root of 3 divided by 2. Okay. A has coordinates 1/4 and square root of 3 divided by 4. How do I know that? Well, you see that's a linear change in here. Okay. So from here you got 0. This point you got half in x. So if you're just going midway, okay, to the midpoint in here, you're just going to go midpoint between 0 and half. So it's 1/4. That's why I put 1/4 here for A. And you're going to go from 0 to from this point to this point, you're going to go from 0 all the way to square root of 3 divided by 2. So I know that midpoint is going to be square root of 3 divided by 4. Okay. Now I put a segment here from A to C. And why did I do that? Well, C is going to be a 1 and 0. Okay. You don't have to worry about the Z coordinates in here, just the X and Y. Okay. Now, why did I do that? Because I have to find out how long this point, the length from E to B. So I have to know the coordinate of this point. Okay. So you see, you have a vector here from A to C. How did I do that? Well, it's going to be 1 minus 1/4, which is going to be 3/4. Okay. You get the value of x for C minus the value of x for A. The value of y for C minus the value of y for A. So the value of y is 0 minus the value of y for A, which is square root of 3 divided by 4. So it's going to be minus square root of 3 divided by 4. And then you have this vector. Now, if you go from point A plus a certain amount t of this vector, you're going to end up over here in C. All right. And great. But I don't want to end up in C. I want to end up in B. So I have to make sure that when you care about the x coordinates of this expression right here, you're going to end up in half. Half of what? Half of x. Once I do that, you see here, for example, let's just worry about the x coordinate for A. So it's going to be 1/4, okay, plus the x coordinate for this AC thing here. And the x coordinate for AC is going to be 3/4. So 3/4 times t, okay, which is a piece of this vector in here. Which piece? This piece right here. This whole thing is going to be equal half. Will equal half because half is the x value of B. Okay. From this, we find that t is equal to 1/3. So I know that if I'm at this point and I use 1/3 of this vector here, I'm going to end up at this point B. Now I can just, you see, I could have done A plus, applied this formula here again, but this time caring about the y values and substituting 1/3 in here for t. But here's the kicker. You got this length in here from D to E, and you got this length from A to C. These lengths are the same. So from here to here is 1/3, from here to here is also 1/3. So now I know that this distance in here is 1/3 of this entire distance. This entire distance is square root of 3 divided by 2. So square root of 3 divided by 2 divided by 3, square root of 3 divided by 6, and that's the value of b here. You know, for people that are smart, you should just watch this video like twice the speed with me with the volume muted, so you're not gonna hear my voice. But I'm just helping people that have a hard time with these things. Okay. So now we know how much the apophthegms go in the y direction. They go 1/3. Okay. So if they go 1/3, let me think here. If they go 1/3, you see here, now we already have a value for h, which is square root of 3 divided by 6, the y value for h. We didn't have that before, and now we do, okay? And we also have a y value for k and j. K and j, square root of 3 divided by 6, and square root of 3 divided by 6 here. Okay, good. We're going somewhere. Okay. Now, I want to find out the vector from g to h. Okay, I want to find out how to calculate this thing. So how do I do that? Well, I probably did the x-coordinate of h minus the x-coordinate of g, and then the y-coordinate of h minus the y-coordinate of g, and the z also, right? Because this is a vector in 3D. So the z-coordinate of h minus the z-coordinate of g, and I just came up with this stuff. I'm just going to make the one here. So 1/2 minus 1/2, you got 0 here, okay? And do the same thing for the others. Now I'm going to apply the same vector math, the same vector reasoning, right? I'm at this point g, and I'm going to take a t part of the vector gh, and from this I know that I'm going to end up at L, because L is the continuation of this vector where it hits the top. Okay, now what do you got to worry about? You got to worry about that this is the g point plus t times the gh vector. Okay, you don't worry about these things here right now. You still want the y. You don't care about the x, because the x you already know what it is. It's 1/2. Okay, now the z coordinate in here you already know too, because it's 1, right? Because L is at the top, so you know that it's 1. So if you do like 0 plus 5/6 times t equals 1, okay, and then you're gonna divide, right? T is equal to 1 divided by 5/6, so t is gonna be 6/5. Gonna be 6 divided over 5 in here. Now you have the t. And now you care about the y. What does that mean? That you're going to plug this value of t, 6/5 in here. And now instead of caring about the z value to find t, you care about the y value. So it's going to be 0, the value of y for g, plus square root of 3 divided by 6 times 6/5. Okay, so 0 plus square root of 3 divided by 6 times 6/5 equals square root of 3 divided by 5. So you know that this question mark in here is square root of 3 divided by 5. So you plug this value into L, right? You have half in here, square root of 3 divided by 5, and 1. And we're going to put that in on the next slide. So you have L here, square root of 3 divided by 5. Okay. And now you want to find out the value of n. Okay, so you found g. From g you go to h. From h you go to L. And using the same logic, I'm just going to show you guys here. You can pause the video and do the same thing that you did over here. Okay, using the same logic, you're going to find the coordinates of n. And now we have the coordinates of n right here. Okay, now what you want is to, let me think, got 38 slides in this stuff. So let me think what I did in here. Let me think. I did so many things. I'm so tired. Y of C is what? Okay, yeah, I'm trying to find out the Y value of C, okay, at the point C, because I want to know how far in the Y direction it goes, the base goes, right? Because this is the base of the prism. See, A here, B here, B here, C here, C here. So I want to know how far this goes. This is an equilateral triangle with a hypotenuse of 1 and a value of 60 degrees here. So you know that this thing here is just going to be the sine of 60, which is square root of 3 divided by 2. Now, the y value for C is the same as the y value for F, which is the same y value for N. So we're going to plug square root of 3 divided by 2 into the y for C, y for F, and y for N. Okay. So you see y for C, square root of 3 divided by 2. Y for F, square root of 3 divided by 2, and y for N, square root of 3 divided by 2. Okay. Now, let me think. What on the next slides I explain things. Yeah. Now I'm trying to find out the value of I. Okay. Because, well, you gotta find out all the values in here. Gotta find out all the values in here, and you're gonna see why. Okay. Now, what was my reasoning here? What is the coordinate of I? You see, when you go from D to F, think about from D to F. What's the value of X here? It's 0. What is the value of X here? It's half. So this is going to be half of half, which is 1/4. It's here. What's the value of Y here? It's 0. And what is the value of Y in F? It's square root of 3 divided by 2. So going halfway, it's square root of 3 divided by 4. And 1, I has a z value of 1 because it's at the top. Okay. Now you want to find out the vector IL. Remember that we already had the IL before, right? We have I here, all stuff, and now all filled out. And now we have the point I here also all filled out. So if you want to find the vector IL, all you gotta do is the x of L minus the x of I, the y of L minus the y of I, and the z of L minus the z of y, and you're gonna find out the vector IL. This GH in here that I put is just the vector GH, okay? Because we're gonna need that later. So I'm just filling up these two tables here. Okay, so now here's the thing. I got the vector IL, okay, which is going from here to here. Now from I you go to L, and from L you go to M. But all you know from these three is that the Z is going to be 1. You have no idea of the X value of M or the Y value of M. Okay, so you have the vector IL in here, but you don't have the equation, the y equals f of x. Okay, you don't have an equation of x of y in terms of x to find out how these things are going to relate to each other. Because if you just use vector without this equation, you will never find the value of m. So you find the equation, okay, for IL. Now, how did I do that? Well, I know that it goes from I and all the way to L, and I know the slope of this vector IL, okay? It's just gonna be this vector right here, minus square root of 3 divided by 20 divided by 1/4. This is gonna be the slope of this function. So knowing the slope and knowing that the line goes through the points I or L, I can just pick each one of these points and use the point slope equation that you learn in high school math. Okay, so according to the points in here, you see this is going to be the form of this formula right here is going to be y minus y0 equals m, which is this is the slope, times x minus x is 0. So it's a point that goes 1/4 and square root of 3 divided by 4. It's the point I that I use. I could have used the point L, but I used the point I. And now I have the function. Not only I have the vector of I from I to L, but I also have a function of y in terms of x, okay, y equals f of x, for this line that goes from I to L. And now what am I going to do? I'm going to find the vector, okay, that goes from F to E, the same way that I did all the others. And then I'm going to find the equation from F to E. And guess what? Now I have the equation from I to L, and I have the equation from F to E. So I can equate these two equations, I can relate them, and they're going to have the same x and the same y exactly at one point, which is the point M. So I know that M has a value of 1 in here for z, okay? But I'm also going to know the x, and I'm also going to know the y, and that's what I did here. I'm just going to show you guys this stuff. See, relate the IL and FV functions to find M, and that's what I did here, okay? I'm not going to bore you guys to death with all these things. You can just pause the video and check this out, okay? Now, find the NM vector. See, N, all the way to the apex of the pyramid, it comes to M. Well, we have N and we have M, so it's easy to find the vector, okay? Just the x-coordinate of M minus the x-coordinate of M, the y-coordinate of M minus the y-coordinate of N, you'll find the vector. Now, guess what? You'll be able to find Q, because you have the endpoint following the same reasoning, plus t times the vector NM, you're going to end up in Q here. And what do you know about Q? Well, you know that from this point here, its x is 1 and its y is 0. So you see, what I cared about in this case in here was the y. I used the y here. When it's a square, it means that I don't care about the x. Could have used 1, which is here, but I decided to use the 0. That's why you have a 0 here, okay? And then I found out t, and from t, I found out z. So I have the x, which is 1, okay? It goes all the way here, so it's 1. And the y 0, because it's not going towards c, okay? It's just here. And the z is half. So now I have the coordinates of Q. All right. The same way I'm going to find O, right? Your N plus T times N, the vector from N to M, you're going to get to O. And O is at the floor. You don't know the X and Y of O, but you know that it's Z0. So you do this thing and you find the coordinates of O. We're halfway, guys. Just cry. Okay. Now, find the OG vector, okay? Because now I have O, I can go from O to G. And now I'm going to find OG in terms of y equals f of x, the equation of this, okay? Of OG, of the OG vector. And now I'm going to find the vector AC. And I'll find AC in terms of y of f of x. And then I'm going to relate the equations of O to G and from A to C, because they're just going to meet, these two lines in here are just going to meet at one point, P, and I'll be able to find P in here, which I have, okay? And now I have all the points. That was fast, okay? I mean, the beginning is excruciating, but hey, it's over. Now we have all the points in here. You see what I did? I don't need all this stuff in here anymore, and G, H, I, L, A, C, because I already have all the coordinates of all the points. So I'm just keeping this stuff in here. Now, here's what I'm going to do. I need to find the magnitude of PC. Okay, because why? Because you see here, this is one side of the base of the large pyramid. Okay, this is one side of the base. So how do I do that? Well, the x value of C minus the x value of P is going to be this one. The y value of C minus the y value of P is going to be this one. And then I just use the Pythagorean theorem to check the square root of all the two sides, and the hypotenuse is going to be from P to C. Okay, so you see here 5 divided by 12, square that, 25 divided by 144, plus 5 square root of 3 divided by 12 is going to be 75 divided by 144. 25 plus 75, 100. The square root of 100 is 10. And the square root of 144 is 12. I simplified this. 10 divided by 12 becomes 5, 6. All right. So now I know the length of PC. All right. The same way I'm going to find the length of CO right here. And now I have two sides. I know how long PC is and I know how long CO is. Okay. Now to find this triangle here, P, C, and O, to find the area of this base, right? All I gotta do is to use this formula, find the large pyramid base area, okay? So it's gonna be PC, which is 5, 6, times CO, which is 5, 4, times the sine of the angle between them, right? Because you see, how do you calculate the area of a, how do you calculate the area of a, well, yeah, I had to divide this by 2 too. Yeah, it's one thing that I forgot to do. It's amazing that it worked. It worked because I forgot to divide by 2 by all these things, as a matter of fact. Okay, so it's going to be this side times this side times the sine of the angle between them divided by 2. Okay, but hey, I'm just gonna leave this stuff in here for now. Yeah, I'm just gonna leave this stuff in here because it just works. So actually it's just the result's gonna be 25 times the square root of 3 divided by 96, not divided by 48. But if you do this for all the triangles, it'll just work. It's crazy. Okay, find the large pyramid volume. So you take the base of the bottom triangle times the height. The height is the z value of n, okay, the z value of n in here, and divided by 3. Why? Because that's the volume of the pyramid. That's the formula for the volume of the pyramid. Okay, it's the base, it's the area of the base times the height divided by 3. So you have this thing here. That's the volume of the large pyramid. Okay. And here you got a magnitude of EF, of IF. I need the magnitude of IF here, which is just half because it's half the length. Okay. Yeah, why do I need this stuff? Because you see, now I need the base of the smaller pyramid, the smaller pyramid that's P2 right here, that's on top of the prism. So the base of the smaller pyramid goes from I to F, F to M, and M to I, right? So I'm just going to get the sides IF and FM. So I get the magnitude of IF. And then I find the magnitude of FM the same way that I found the magnitude from CO. And then I find the smaller pyramid base area, which is one side times the other side times the sine between them, which is square root of 3 divided by 2. And of course it's supposed to be divided by 2 again, but it just worked. Because I made the same mistake consistently, so it worked. Okay, now find a smaller pyramid volume, okay, which is the base that we found here, P2, times the height. Now what's going to be the height? The height of the smaller pyramid right here is going to be 5 divided by 2, which is the height of the entire pyramid, the larger one, minus the height of the prism. The height of the prism is 1. So 2.5 minus 1, 1.5. That's why you have this 3 halves in here, divided by 3. So it's the base of the area of the base times the height divided by 3, and you got the volume of the smaller pyramid, which is the one on top of the prism. Now you're gonna do find the magnitude of BO from here, same way, okay? And find the smallest pyramid base area. It's this pyramid right here. It's kind of hard to visualize, but it's the pyramid that comes outside of the prism. If you go back to the beginning of the video, you'll be able to see that a little bit of the larger pyramid comes outside of the prism. You don't want to take that into account. You want to subtract that. So one side of this pyramid is going to be BO, and the other side of this pyramid, one side of the base of this pyramid is going to be BO. Okay, not one side, one edge. And another edge of the base of this pyramid, the small pyramid, is going to be BG. So you're just going to multiply these two lengths times the sine of 120. Why is it 120? Because you see, you have, how can I show this to you guys? From C to B and from B to O, let's just say that you have a vector here and you sweep it this way. You're going to sweep 180 degrees. But from C to B and B to G, you have a side here that's 60 degrees. Okay, so the angle between the edges BG and BO is going to be 120. And the sine of 120 is the same as sine of 60, which is square root of 3 divided by 2. So you're just going to do that. Okay, so find the smallest pyramid base area. So it's going to be 1/2, which is BG, times 1/4, which is BO, times the sine of the angle between them. And it was supposed to be divided by 2 too, but I forgot consistently and it worked. Now I have the base area of the smallest pyramid, this one. And with that, I can just multiply by the height, which is going to be from point B to Q, which is 1/2. And I'm going to find and divide it by 3, and it'll be square root of 3 divided by 96. That'll be the volume of the smallest pyramid. Almost over. Okay, now you want to find the pyramid volume that intersects the prism. So it's going to be the largest pyramid minus the smallest one in here minus the pyramid that's on top of the prism. Okay, so you already have all these volumes in here, and you just P1V minus P2V minus P3V, and you're going to have this volume here. This volume here is going to be the volume of the largest pyramid that's inside the prism. That's actually what you care about. It's the largest part of the prism that's on the other side, that's behind the glass. It's behind the plane. And now you find the prism volume. So you want to find the volume of the whole prism. Okay. How do you do that? Well, it's gonna be the area of the base. Okay. It'll be the area of the base times the height. And this time you don't have to divide it by 3 because it's not a pyramid, it's a prism. So it's just going to be 1, which is this edge, times 1, which is this edge, times the sine between them, which is square root of 3 divided by 2. You would have to divide that by 2 again to be square root of 3 divided by 4. And you multiply, and you multiply by the height, which is 1. Okay, so you have that. Okay, you have the volume of the prism. Now you're going to subtract the volume that's inside of the pyramid, that's inside the prism, from the volume of the prism. And you're going to get this thing right here. This volume is actually the volume that's closest to the camera in front of the glass, in front of the plane, that's closest to us. Okay? And now all you got to do is to divide this one by this one in here, and you find it. Look at that. All right. And that's the question. That's the answer right here. 49 divided by 95. That's it. It's crazy.